Right then, connected particles time. So two particles A and B of mass m and 2m respectively are attached at ends of a lightly extensible string. Particle A lies on a rough horizontal table, so that's going to have friction, and B hangs freely below the pulley. The coefficient of friction between A and B is mu. Particles are released from rest with the string taut. Immediately after the release, the magnitude of the acceleration is 4/9 g. By writing down separate equations of motion for A and B, find the tension, show that mu. Right, okay. So, let's just annotate the diagram first of all. So if we think about the forces acting on A, we're going to have a tension in the string. It's rough, so we're going to have friction acting that way, because this is going to accelerate in that direction. We'll have a normal reaction, and we'll have a weight, and the weight will be mg. Then on B, the weight of the particle will be pulling it in that direction. The weight is 2 mg. The tension is going to be the same because the pulley is smooth, and this is going to be accelerating with the same acceleration. So that's what we're working with. So if we now set up our force equations, so at A, we've got Newton's law acting in the direction of acceleration. So I'll have T minus F equals mass, which is m, times the acceleration, which we know is 4g/9. We've also got that r minus mg equals 0, because there's no acceleration acting in that vertical plane, and we know that F equals mu r. So I've got 1, 2, 3 equations there, and then at B I'll be back into Newton's second law. Direction of motion is positive, so 2 mg minus t equals the mass, which is 2m, times the acceleration, 4g/9. So those are my 4 equations. I can see straight away that equation 4 has only got one unknown, which is t, so I can use that for part A to find the tension. So from equation 4, t, if I take that over to make it positive and bring that over, I'll have 2mg minus 2m 4g/9. My tension is going to stay in terms of m. So what I've got then is 2g minus, so if I take the m out, I got 2g minus 8g/9. So I've got, if you remember from class, I store g in F, so I'm going to have 2f minus 8f/9 equals 98/9m. Newtons. Okay, so the tension in the string immediately after the particles begin to move is 98/9m. Quick slip of a cup of tea, and then B. Show that mu is 2/3. So B. Right, so I now know what T is. It's that, so I'm going to store that in X, because I'm going to be needing that later on. So in order to get mu, I need F and R. So from 3, mu is F upon R. So R is mg. So I now need to substitute T into equation 1. Sub T in 1 to get F. So in 1 I'll have 98 over 9m. I'll take the F over to make it positive and bring this over, minus 4g over 9 m equals F. So on my calculator, 98 over 9 minus 4 g over 9 equals 98 over 15. So F equals 98 over 15 m. So R is mg, F is that. So mu will be F, which is 98 over 15 m over mg. So the m's will cancel. So basically I'm going to divide that now by 9.8. Which equals 2/3, which is what we're required to show. Equals 2/3 as required. Okay, so that was the connected particles question.